If you find the answer correctly, then you get extra points. But if you get the derivative correctly, then you get the points for the derivative, for the actual point for the quiz.
How about like
Let's see. So, derivative. F prime of x. What's the derivative of 2x cubed? Oh, before we find the derivative, let's find the numbers for here and numbers for the other power. So 2x cubed minus 3x to the what power? 1/2 power. Not now, I'm taking the derivative yet. And then 5x to the what power? -3 minus 1. So now we have all the powers as a power. So we can find the derivative directly. What's the derivative of 2x cubed? 6x squared. Minus 3 times. What's the derivative of x to the 1/2? 1/2 x to the -1/2. Right? 1/2 comes down and then 1/2 minus 1. Plus 5. What's the derivative of x to the -3?
I have a question. If I told 1.5 to 2, is that fine?
It's fine. So what's the derivative for the last one? X to the -3? -3 x to the -4. And Jawad, what's the derivative for -1? That's a mistake.
Oh.
Derivative of a constant is 0.
Yo, I even asked that, and he wasn't paying attention. I get it, but I was under pressure. Alright, I finished first, by the way.
So we are going to do the multiplication now. We have a -3/2 and 5 times -3. And this is a negative power, this is a negative power. So we are going to rewrite everything nicely. We have 6x squared minus 3/2 square root of x on the bottom minus 15 x to the 4 on the bottom. So this is the final derivative. As long as you have this correct, you are not going to get any points taken off. Okay? So this is the correct derivative.
Yo,
Now we are finding this derivative when x is 2. So 6 times 2 square minus 3/2 x, 3/2 square root of 2 minus 15, 2 to the 4. So now this is extra credit for now, for today. We have 6 times 4, 24. And this is 1.5 over square root of 2. But we don't know what is square root of 2, so leave it alone. Minus 15 over 16. If you got at least this correct, then you get some extra points.
Wait, I got that correct too.
You have to get everything correct.
No, I got some of that correct.
So like, I didn't put 1.5. I just left it as 3 over 2.
Square root of 2.
Yeah, me too,
Fine.
me too, me too,
It's fine.
me too. I get that. Okay.
I mean, no, I said this is 1.5 and 3 over 2 are same thing. So
No,
what version
no,
is correct?
I did the date, there were 2.
And then you can also find this two if you want, but you don't have to in the right now. For now, you don't have to.
Wait, why?
You can combine these two because this is not a calculator portion. For if it's in the calculator portion, you have to find all of them and then get the final result.
Also, you say this people.
For now, you leave it alone, but for calculator, you have to do this.
Oh, you can leave it.
You are going to go to the calculator and find the final answer.
You can like leave it, 3, 2, 2.
3 over 2, you can. This is not wrong, this is right. So we have 24 minus 1.5 divided by square root of 2 minus 15 over 16, 0.05, 0.057. 0.057. So if you see this part, this question in the calculator part in the exam, you need to find the final answer. But in the quiz, thus this is fine. Okay.
So I could get that one.
Ready?
Yeah.
Zoe. 3 over 2, square root of 2, you're fine. This is not wrong, this is correct. Yeah. It's correct. You can leave it alone. And next time, please write neatly. The paper I saw, I don't even want to grade that. Okay. When I'm going to grade your paper, I will definitely get a head problem.
Question. Do we have meat handwriting? Do we get like?
Surprisingly, I actually do that.
Oh shit!
When I see someone very neat and clean,
Yo, that's
I
me.
get so happy. I get extra points.
Me. So what's my-
Really, I wish. I really wish.
It's me. Look.
Yeah.
Me. You look at it.
Ready? So today we are going to learn new few rules. There are 4 more rules.
What was it going?
4 more derivative rules. And they're big rules.
Why is 10?
Okay. Today's rule number 1 is called product rule. What does product mean? Multiplying. So the product rule comes from 2 functions multiplying together. If you have 2 functions, f and g, or 3 functions or 4 functions, it doesn't matter. If you have multiple functions multiplying with one another, to find the derivative, what you do is you take the derivative of one function, leave the other function alone, plus take the derivative of the second function, but leave the other functions alone. Okay, that's how you find the derivative of product of many functions. So if you have 2 functions, f and g, its derivative is f prime g, so f prime times g plus g prime then f. So product, when you multiply, we get something more, right? Same thing when you add, we get something more. So product rule gets the plus sign. Later, we are going to learn that quotient rule, and we are going to use the minus sign. So product rule gets plus sign. When you take the product rule, they find the derivative of one function at a time. So one function derivative times the other functions, the original ones, plus then you change the second function. So derivative of the second function multiplying by all the other functions unchanged. And then based on how many functions you have, you do the same process again and again. Okay? So to remember this kind of fun way, I have this picture. This picture is showing that Dora and Caillou, do you guys remember them? Dora and Caillou? So Dora and Caillou, they are arguing about a bicycle. Let's say the bicycle is a derivative, okay? So whatever gets the derivative, he is happy. So since in 2 functions, we cannot have the same bicycle, give them together, not together, give them at the same time, right? There's one bicycle, so only one person can get the cycle. So first, the Caillou got the bicycle, so Caillou is happy. So derivative of the first function is happy, we got the derivative. But the second function stays same, okay? It doesn't change. Plus, then the second person get the derivative. So second person got the bicycle, and the first person stays same, okay? So it doesn't matter how many functions you have, you're allowed to change only one function at a time. So you change one function, multiply by all the other functions. So here we have only two, but let's say we have 4 functions. Find the derivative of f times g times h times, let's say k. How do you find the derivative? First, you find the derivative of one function, multiply by all the other function unchanged. Then plus, take the derivative of the second function, multiply by all the other functions unchanged. So FHK. Plus, next take the derivative of the third function, H prime. Multiply by all the other 3 functions unchanged. So F, G, and K. And the last thing we have is the last function to find the derivative of. So derivative of K times F, G, H. Take the derivative of one function at a time and multiply by the other functions, the original ones.
Yeah. Gotcha.
Ready?
I'm gonna leave later.
So let's take the derivative of this function. Yes, you can distribute, but then you are not going to learn the product rule. So without distributing, using the product rule, how do you find the derivative? So it says, find the derivative of this function respect to the variable x. This is what it means. What's the derivative of this function respect to x? So let's say the first element here is f, and then the second function here is g. So the derivative here will be f prime times the function g plus g prime times the function f. So if f is x to the 5, what is f prime? 5x to the 4. And keep the g function unchanged, same exact g function. Now you're adding. If g is 2x cubed plus 1, what's the derivative of g? Six x squared plus 0. But 0 doesn't count, right? So leave the 0 alone. Times your f function, which is x to the 5. So this is the product rule. So we are done with the derivative, and then you're going to simplify.
Oh. Wait, what's
Okay, let me do it on the side. Our f is x to the 5, so f prime is 5x to the 4.
wait, what do you mean by G?
Our g is 2x cubed plus 1, so g prime is 6x squared.
How do you find G prime?
What is the g? What is the g function?
G function?
Your g function is 2x cubed plus 1. So what's the derivative of g? Prime means derivative. So 6x squared and derivative of 1 is 0.
Oh, that's easy.
So the algebra says distribute, so we get 5 times to 10, x to the what? 7. Plus 5, x to the 4, plus 6, x to the 7. Do we have any like terms? Which ones? This and that. So we get 16, x to the 7, plus 5, x to the 4. Product rule is the easiest rule after power rule.
Well, the first one's easier.
First one is the power rule. So first one is the easiest one. The next is this one, product. Then we have a new rule. Since we learn product, that means, yeah, I have lots of example. Once I introduce you to all the rules. Today we're going to learn two more, and then tomorrow we are going to learn, yes, so one more, and then one more, and then tomorrow we're going to learn a new one. Okay, so three more rules. So since we learned about the product, now it's time to divide. If we have two functions dividing one another, you do almost same thing as the product rule, but there are two things different. The different thing is that on the top, you do the product rule. F prime, I missed my G, so let me write my G. F times G of X. So if you have two functions, then the top function is F, the bottom function is G. Then the product rule says, the quotient rule says, take the derivative of the top first, multiply by the denominator function. And now since you're doing division, so you're going to get something less, not more. So don't add, instead subtract. Subtract what? Take the derivative of the denominator function multiplied by the numerator function. So product rule was F prime G plus G prime F. This is almost same, but the difference is it's not plus, it's minus. And then the second difference is once you have the product rule on the top, you divide by the denominator function square, not the derivative, only the function square. Okay, so this is the shorter version. F prime G minus G prime F divided by G squared.
What does that say?
F over G whole thing prime is F prime G minus G prime F divided by the denominator function square, G squared. There is an expression actually many people use. Let's say if this is your low, means the denominator, and this is your high, means the numerator, then its derivative is an expression low d high minus high d low divided by low square. This is the expression. Low d high minus high d low divided by low square. What does that mean? Means the denominator times the numerator derivative minus numerator times the denominator derivative divided by the denominator square. Low d high minus high d low divided by low square.
What was low and high?
Low means the denominator, high means the numerator. So it's a nice expression, low d high minus high d low. So I see many students, they don't remember the rule, but they remember this expression. Jerwin, I'm going to take your phone now. This was your last chance. Okay, if I see your phone one more time, your phone will be here. Salahuddin, same goes to you. Your phone. Because this is a classroom, the phone should be on the top, in front of me, if you're using in the class. Example, let's say we have two functions, 4x plus 3 divided by 2x minus 1. Thank you. Let's say purple. Let's say this is the f function and this is the g function. Okay,
So when we have a quotient, they're not gonna give us two separate functions, or is it like this?
like this.
So we don't get
We
like.
do have two different functions. The numerator is one function, denominator is another function. They're not same, they're two different functions. So you take f function, you said f is the top one, 4x plus 3, and your g is the bottom one, 2x minus 1. So then what is f prime? 4? Only 4, right?
Yeah, 4.
Because derivative of 4x, do you remember? What's the slope of a line? This is a line, right? 4x plus 3. What's the slope of the line? 4. And what is g prime? 2. So we have our f prime and we have our g prime. And now we find the derivative.
Why does it do that?
Hmm?
Why does it do the x?
So we have 4x. If you want to use the power rule, what's the power on the x? 1. What's the power rule?
Minus 1.
Power comes down, power minus 1. So you have 4 times 1, 4, x to the 0. What is x to the 0? 1. Or you can use the slope formula, not the formula, the slope concept. We have y equals 4x plus 3. It's a line. So this is your m, this is your b. It's y equals mx plus b. And m is the slope. Derivative is the slope. Okay, so f prime g. F prime g minus g prime f whole thing divided by f squared. What is f prime?
4.
4 times g. What is g?
But minus
2x minus 1 minus g prime. What is g prime? 2 multiplied by f. What is f? 4x plus 3 whole thing divided by 2x minus 1 in the second power.
Is it?
Hmm?
Yeah, dx.
Yeah. Oh, g, sorry, I did it. Come on. It's g square. So my color should be green. G square. So this is the derivative. Derivative is done. But then you have to do algebra.
But you have to solve it.
Simplify, not solve, simplify. So we distribute, and we get 8x minus 4 minus 8x, and then what? Plus 6? It should be minus 6 because negative 2 times 3, negative 6. And 8x cancel out. So what do you have? 4 and 6 gives us. So we have negative 10 over the denominator. Do not distribute the denominator. We need to keep the denominator unchanged. Because sometimes when you simplify the numerator, we can cancel something with the denominator. Not always, but sometimes. Any question on this derivative rule? So which one is easier, product or the quotient?
That's the final answer.
Low B, high, high.
Mm-hmm. Okay, so now we are going to do more here. It says once you have your derivative, find the equation of the tangent line at x equals 1. Do you remember how to find the equation of the tangent line? Okay. What is equation of any line? Equation of any line. It's y equals x plus b, but also there is another one, right? Y minus y1. I like to use this one because we can see what is given and what is not given. This x1 is this. So we need to find only two more things. Which two things we need to find? The slope and the y1. Y and x, they will be inside your equation. So we only need to know what is m and what is y1. So let's find y1 first. How do you find y1? We are given the x1, right? X1 is 1. Then how do you find y1? Plug in that into which equation? The derivative of the original one. The original one. Because x1 is on the original one. So your y1 must be from the original one. So original equation is 4x plus 3 divided by 2x minus 1. All these x you see, they are 1. So it's 4 times 1 plus 3, 2 times 1 minus 1. So 4 plus 3, 2 minus 1, what do we have? 7 over 1, which is 7. Why don't I just leave the denominator? So we found our y1. So we have x1, we have y1. Huh?
Where you just, where, other one is 2x minus 2, where's that from?
I'm not using derivative, I'm using the original function. Because the x1 is from the original function. So to find its pair, the y1, you must go to the original function. And now the only thing we don't know is the m. How do you find m?
Delta y. Delta y over delta.
It's for a line, but here we don't have a line, we have a quotient. What's the slope? What's another name for slope? Derivative. So the slope is the derivative, f of x, but derivative is an equation. We cannot plug in an equation here, right? It doesn't make sense. We need a number. So how do you find the number for our slope? What do you plug in for x? 1. So when you plug in to the original function, you get y1. When you plug in x into the derivative, you get the slope. So our slope is negative 10 over 2x minus 1 whole thing square, which is negative 10 over 2 times 1 minus 1 whole thing square. Actually, let me do it on the side so I have enough space. Negative 10, 2x minus 1 square means negative 10, 2 times 1 minus 1 square, which is negative 10 over 2 minus 1 square. And what is 2 minus 1 square? 1. So negative 10 over 1, which is negative 10. So the equation of the line. Equation of the tangent line. Y minus 9x minus something. Y minus what? 7 equals what? Times x minus 1. This is the equation, but they actually want you to solve for y. So you need to distribute here, and you need to add 7 to both sides. So negative 10x plus 10, and then you add this 7. The final answer is y equals negative 10x plus 17. So if they say only find the derivative, they will say find the derivative or differentiate. And then if they want to find the equation of the tangent line, they will say find the equation of the tangent line at this point for this function. So once you find the derivative, you need to find your slope by substituting x value into the derivative. Then you need to find the y value by substituting x into the original function. Once you have both the numbers, you substitute into the point slope format and then solve for y. Any question? Let's see what's next. Our last rule for the day. So today we learned product rule, power rule, and now the last one, chain rule. So many rules. So try to write them down in one page. And anytime you do any of the homework on the derivative, have the page available in front of you. You will. That's I'm telling you the methods to remember them. Write all the steps down in one page.
I got with the pages.
No, I said rules. All the rules in one page.
Wow.
Exactly.
This is the rule.
No, these are examples. These are the rules. I boxed all the rules for you. The chain rule. So chain rule has two parts. Depending on which format you have, you apply the chain rule differently. If you can see visibly, you have one function inside another function. So the chain rule is specifically for the composite function. Do you remember what is composite function? What do you do in composite function? Or how do you get composite function? How do you get composite function? Huh? Wisa, what is Wisa?
Huh?
What did you say?
What's that?
Oh, what's that? We did composite function, you already forgot. Composite function. You don't remember? Huh? No, that's the power rule. Composite function, it means you put one function inside another function. It's composite function. So when you have a composite function, the chain rule is specifically for the composite function. So what you do? Since there is one function sitting inside another function, so when you apply the derivative, same thing, you're only allowed to change one function at a time. So first you change the outer function. So take the derivative of the outer function, leave the inner function alone. Remember, derivative is very weak. It can only change one function at a time. Whether it's a multiplication, division, or chain rule. Everywhere, it only can change one function at a time. So change the outer function first. So derivative of f, leave the inner function same inside the derivative. And then times derivative of the inner function. So product rule use plus sign, quotient rule use minus sign, but chain rule use multiplication sign. So f prime of the g times the derivative of the g function. And when you see there is a power on a composite function, then you use the power rule. Power comes down, power minus 1. So that's the derivative for the outer shell, but leave the inner shell same. Do not change the function inside the power. And then you multiply by the derivative of the inner function. So if you see a power use the power rule first on the outer part, but leave the inner part unchanged. Once you're done with the power rule, then multiply by the derivative of the inner function. Oh, to remember this, I have another scenario. Let's say two balloons. One is inside another one. So what's the chain rule? The chain rule says you can change one function at a time, means you can pop only one balloon at a time. So when you pop the one balloon, it means you're taking the derivative of the outer function. And then times, when the inner function is alone, now you can pop the second function, the second balloon. So it's derivative of the second balloon. Okay. Example, something like this. We have 3x squared plus 1 whole thing to the power 6. So we have a function here. And this function has a power here. No, it's a chain rule. Because we have two functions sitting inside one another. The outer function here is the power. Whatever you have on the power, that's your outer function. And your inner function is whatever you have inside, which is, let me change the color to red. 3x squared plus 1. So this inner function goes inside the outer function and you get this composite function. So the rule says, since the power is the outer function, use the power rule. So f prime of x. What's the power rule for the power 6? 6 comes down, right? 6 minus 1. So this is the derivative of the outer shell. 6 comes down, 6 minus 1. Since you change the outer shell, you cannot change the inner function. So leave the inner function unchanged. Derivative can change only one function at a time. So you change the power 6 to power 5. So you cannot change the inside. So once the 6 comes down to 5, then you can change the inside function. So you take the derivative and multiply next to that. What's the derivative of 3x squared plus 1? 6x. That's the chain rule. Change the power first. Don't change the inside function. And then multiply by the derivative of the inside function next to your power. So this is the derivative. The derivative is done. Now the algebra. How do you simplify that? We have 6 times 6x. We can combine them. So how many x we get? 36x. And this thing has a power, so we cannot do anything. It's too powerful. So we leave this alone. Yep, that's it. Question?
Why do you leave the 3x squared?
Because derivative cannot change two things at a time. You changed the power 6, so you cannot change your inside.
Yeah, example.
Oh, we are not done, right? Because it says once you find the derivative, now find the derivative at 1.
Oh,
So second part.
I basically.
What's the derivative at 1? 36 times what? 1.
Why are you?
And then 3 times 1 square
Oh yeah.
plus 1 whole thing to the 5.
10 to power 5.
Where you get 10?
What did you do? Wait, 3 to the power 2?
It's not 3 to the power 2, it's 3x to the power 2. So your 36 times, this is 3 plus 1, 4, 4 to the power 5. And we have no idea what is 4 to the power 5, whatever that is.
That's the answer. We don't even solve it. Shoot.
Without calculator, you cannot do it.
Yeah.
With calculator, you can do it.
4 plus 16.
4 to the 5 is a big number. Okay, another example.
I got first one. What you mean? Is this for chain move? Yeah. Chain move? I got this. Basically.
Do you see the power here for the outer function? So what is your first step?
It's 1. That's 1. What? It's not 1.
The power for the outer function. 1/2.
Oh wait, because it's the square root.
Mhm.
Okay.
So your step 1 should be rewrite
Yeah,
this using a power so that you can see the power. So x squared plus x plus 1 whole thing raised to the power 2. So go ahead, try to find the derivative. You already got the derivative?
Yeah.
What is it?
I can't say it. Hi.
No?
1/2 comes down and then 1/2 minus 1. So that's the derivative of the outer shell.
Yeah.
Once you're done, what do you have to do? Do you only change the outer
And
function?
then you take this, right? And then-
Multiplied by derivative of this.
So,
Oh, I got it.
okay, what's the that?
Really? What's the derivative of the entire inside function?
The entire one?
The entire function inside.
Oh, I got it.
So you find the derivative of the first term, but your function doesn't have only one term. It has 3 terms.
You find the derivative. Like that.
You multiply by the derivative of the inside function.
Yeah, I got
this, so like the question is,
How do you?
am I supposed to do anything from here, or is that, you said you can only do one at a time, it doesn't only apply to other people.
You change both of them at the same time.
How do I not?
I mean, you didn't even change the outer function. You cannot leave the outer function but change the inner function. First, you have to see the derivative of the outer function,
Okay.
but leave the inside function same.
Oh,
So outer always should come first,
Oh, I thought I changed it.
and then multiply by derivative of, this thing here.
I got it wrong.
Oh, alright.
Mhm.
Now.
No, I
Okay,
kinda need
yeah.
help, I kinda need help. Isn't that this, or no?
No, you have to put a parenthesis.
Oh, this is it. Like this?
I
Yeah,
have to get 1/5.
so this is it? Cause,
Yep,
cause,
and then you
cause look,
take,
and I decided, cause I put this on the bottom. Nope.
but I have to get 5.
Oh wait, 1/2.
Good, you are one step advanced, no problem. So this goes on the bottom, this is 2, but you're half done here. Because you took the derivative of the outer function only. What happens to the derivative of the inner function? You have 2 functions, you have to change 2 of them one at a time. So first you change the outer one, good job. And then at the same time, the next step, you multiply by the derivative of this function.
Oh.
So what's the derivative of this
So
function?
that's the derivative of the outside function, and then,
That's the inner function.
oh, so wait.
So this will go on the numerator. So once you have it here, write it down.
X, x1 plus
What is x squared? Derivative of x squared.
x squared is, x? Wait. Yeah, it's x. Wait, 2x. 2x
And
Plus-
it's what?
plus x.
What's the derivative of x?
1 plus 1. Oh, that's it?
That goes on the numerator
Wait, why on the numerator?
because it has positive power.
What? Wait, so it's like
This
minus?
one has minus power, so this part goes down. But this polynomial have 1 power, so it has to go on the top.
Oh, so this is on the top?
This has positive power and this has negative power. Every negative power will go on the denominator. Every positive power will go on the numerator.
Wait, can you write it all?
Why did you do this?
Oh, wait. Alright, so
Is it
one,
right, or I do something wrong?
How'd you get 5?
Yeah.
If you multiply 1/2 times this, the 1. Isn't
that,
Where'd you get
that's
5?
1/2.
Point, yeah.
That's
0.5.
1/2,
Oh,
dog.
what's 1/2? 0.5.
Oh, 0.5, okay.
Oh, 0.5. Oh. Oh.
So now,
Right, and then you put 0.5 next, and then 2x plus 1 together.
I multiply this by this. Okay.
Alright, so 1/2. What do now? So I put this on the bottom. X plus X. Oh, wait.
Okay.
Oh, X squared. Like this
And then this one goes on the top.
on the top. Alright, so
It doesn't have any negative power.
2x plus 1. And then I solve it.
It's derivative. You already simplified it. No.
No.
That's because a past mistake is this is not only 2x. Derivative x squared is 2x, but also derivative x.
Oh, you can solve the entire thing.
Entire function.
Okay.
And that entire function will go on the numerator, and the negative half, that will go on the denominator. Let's do it together, guys, if you are not sure.
Got it.
So derivative. Our outer function is the 1/2 power. 1/2 power with the parentheses. So we are going to take the derivative of the 1/2 power. So 1/2 comes down, and then 1/2 minus 1. What is 1/2 minus 1? Negative 1/2. So that's the derivative for the outer part. So you change the outer part, that means you cannot change the inner part. X squared plus x plus 1. It has to stay same because derivative doesn't have enough energy or enough power to change two things at a time. It changes only one thing at a time. Once you are done with the outer, then you can multiply by the derivative of the inside function, the entire inside function, which is 2x plus 1. Derivative x squared is 2x, derivative x is 1. It's 2x plus 1. The derivative is done. You found your derivative. Now you just have to simplify to make it look nicer. 2 is on the denominator, and this thing is even the denominator because of the negative power. So we have two things on the denominator. One is 2, and one is x squared plus x plus 1 with the 1/2 power. But 1/2 we can read it as a square root. So we can actually do square root instead of 1/2. And we have 2x plus 1, this thing on the numerator. 2x plus 1.
Find the inside. You find the inside only. So it's positive 2x.
So this is a derivative.
Why does that go on top?
Because the entire thing has positive power. Every positive power will go on the numerator, every negative power will go on the denominator. So this thing has a negative power, it goes on the denominator. 2 is already on the denominator. And the extra inside, it has a 1 power positive, so it goes on the numerator. And then we do the next part. This 1/2.
1/2. And then you bring the negative to the bottom and positive to the top.
You already have 2 on the denominator, right?
Look, 1/2. Then you bring this to the bottom. So 2, then this keeps this, and this would come. But this is
So derivative at -1 means 2 times -1
you bring this
plus 1
here, and then you
divided by 2 times -1 square plus -1 and then plus 1. So you substitute x Three of the axis is -1 and simplify. The +1, -1 cancel out. On the numerator, we have -2 plus 1. On the denominator, we have 2 times square root of -1 square. So -1 square is +1.
Like what?
So what do you want the numerator? -1. And on the denominator, 2. This is our final answer. The derivative at x equals to -1 is -1/2.
With two variables, one and two.
1 is square root of 1 square. Sorry, -1 square, what is -1 square?
Oh.
+1. And you have 2 times the radical square root of 1. Okay, so in our next class tomorrow, we have few good examples.
Give me reason so I can make my.
Next week again, you're going to have another quiz. Tomorrow, no, not tomorrow.
Raise my
Um,
data.
This, you get this one right.
So tomorrow,
Looks like
we
I
are
got it
going
right,
to
dog.
do few examples. And actually, I'm going to give you the last rule next week. Tomorrow, we have bunch of work to do.
Wait, what's a group quiz? What's a group quiz?
Later in the semester.
And we could pick, right?
I'll think about it. Okay, guys. So see you again tomorrow. Have a good day. Even though it's rainy, be safe. Don't sleep. Tomorrow. Inshallah. It